is the tutorial for the review of chapter 11.1, 11.2, 11.4. So add, subtract, multiply, and divide rational expressions. Let's take a look at our first problem here. And on this one, what we want to do is we want to simplify the expression by taking out common factors from each of these terms. So looking at the first one, I see a common factor on the top of the fraction, and I see a 6. And so I'm going to take out that 6. And from when I do that, I got to make sure I divide each of the terms by 6. So 6 goes on the outside of a parenthesis. I do the division, I have p minus 5 inside the parentheses. And you can always check to see if you're doing it right by multiplying the 6 over that subtraction, and you end up with 6p minus 30, the same exact expression we have on top. So we do the same thing on the bottom of the fraction, the denominator, and we take out the common factor of 3. So that leaves me with p minus 5. And so I see that I've got some common factors. See, the p minus 5s will cancel out now because they are the same factor on both the top and the bottom of the fraction. 3 also goes into 6 2 times, so my answer is 2 over 1, or just 2. But they also ask for the excluded values. The excluded values are the numbers that you would make 0 in the denominator. So you try to find the value of the variable that makes that 0 in the denominator, and the way you do that is you just take the factor that has a variable and you set it equal to 0. And so in this case I just have to add 5 to all sides, and so I get p equals 5. So that's the number that if I put 5 in place of p here, 5 minus 5 makes 0. And you can't have 0 in the denominator, so that's your excluded value. So in this next one, when I have a trinomial, I'll be able to factor it as 2 binomials most likely on these problems. So this one will factor to an n minus 1 and an n plus 5. So I look for the numbers that multiply to make the last term, and subtract in this case, because it's the last term's negative, to make positive 4, and that's the factored form. Down below I've got the n plus 5, and you can see now you can cancel out the n plus 5s, and you're left with the expression of n minus 1. So the excluded value is the number that would make this expression 0 in the denominator. So the only number is negative 5. So negative 5 and 5 makes 0, and you can't have 0 in the denominator, so that would be the excluded value. So again, you can always set your expression, the n plus 5 equal to 0, and you can see how to come up with that value. So n does not equal negative 5. So on this one, we're supposed to write a ratio of the area of the shaded triangle to the area of the rectangle. And so you just have to look at what the directions ask for, and it says what is the ratio. So ratio is comparison of two numbers of area of the shaded triangle. So we'll end up with the area of the shaded triangle. I'll put that in here. Area of shaded triangle all over, and so it says that right there, that word 2 represents the fraction bar, so the ratio of the area of the shaded triangle, that goes on the top of the fraction. The word 2 kind of separates the two expressions, and so we're going to have the area of the rectangle down below. And we'll start off with the area of the triangle, so the formula is 1/2 base times height. Area of the rectangle is just base times height. So looking at this, it looks like the height of this is x, because that goes from the vertex down to the opposite side, making a right angle would be x. So I'll have 1/2 x times by the base, which is also x. Down below, I've got the base is x and 8, so x plus 8. And the height of this is just x. The height is x, and so I go ahead and multiply. So I've got 1/2 x squared all over x squared plus 8x. And so now I'm going to go ahead and simplify this a little further. I can take out a common factor of x, and before I actually multiply it out, I should have looked for those common factors first. So I'm going to go ahead and undo what I did here and take out that common factor of x first. And I see it right here. See, since the x is being multiplied by x plus 8, I could take out those common factors of x, and that'll make it easier. Also, whenever I have a fraction and another fraction, whatever the denominator is here is going to go in the denominator of the second fraction, because multiplying by 1/2 is the same thing as dividing by 2. So I can rewrite this as x over 2 times by x plus 8. You see that 2 times x plus 8, the 2's in the denominator now, so that means divide. So divide by 2 would be the same expression there. So let's take a look at the next few problems here. We're going to multiply next. And so when I'm multiplying, before you multiply straight across, what we want to do is look for factors. And so I'm going to write this as one big fraction, since everything's being multiplied. I wrote the 3 first, then I'm going to factor that x squared minus 4. So oftentimes you're going to see a binomial, and it'll be a difference of squares on these types of problems. In this case, this one factors to an x minus 2x plus 2. And then down below I've got the x minus 2 and the 12. So I look for the common factor between these two terms, and I see an x minus 2, and I see 3 goes into 12 4 times. So I go ahead and multiply what's left over, or just rewrite what's left over. X plus 2 is on top of the fraction. 4 is the denominator. Now you cannot cancel the 2 and the 4 because it's not really 2 on top, it's 2 more than x, and so I have to leave my answer in that form. So with the division problems, I got to remember to multiply by the reciprocal. By the reciprocal. That's the key. So once I see the problem, I'm going to go ahead and rewrite the first fraction, but in a factored form. So I take out the common factor of x between these two terms. I've got x plus 2. So this is another common mistake, is that people think, especially if this were a minus sign, this were 4x, people think it's a difference of squares. But look for the common factor first, and you might be able to reduce it. So now I'm going to multiply by the reciprocal. So I'm putting the x plus 2 on top of the fraction, and the 30x squared on the bottom of the fraction. So now I can go ahead and reduce. So I see the x plus 2's cancel out. I see this x here will cancel out one of the x's down below, and 5 goes into 36 times. So everything canceled out on top, but you still have the number 1. So when things cancel, you're left with 1. And so I look down the bottom, it looks like it's just a 6x squared. So 1 over 6x squared was the answer there. On the adding and subtracting, you got to come up with a common denominator. So on this fraction here, it has a 3b, and this one b plus 2. So I'm just going to multiply by the other's denominator, since they have no common factors. Even though they both have b, b is a factor from this expression on the left-hand side. B is not a factor of the expression, the denominator of the right-hand side. It's b, 2 more than b, so I have to multiply by the other's denominator to be able to solve this, or simplify it. So on this case, I'm going to end up having to use the FOIL method to multiply out these two binomials. So I'm left with 4b squared minus 2b plus 8b, and then minus 4. So I just use the FOIL method for the first two terms. And I'll do the same thing for this next one. So it's addition, so no need to change any signs. And multiplying b and 3b makes 3b squared. So down below, I just write the two factors. Don't multiply them out. It'll be easier if you just leave them in the factored form, because there could be a chance that I'll be able to reduce something after I'm done doing all the simplifying in the numerator. So 4b squared, 3b squared makes 7b squared. Negative 2, positive 6 makes a positive, negative 2 plus 8 makes a positive 6b. And then the minus 4. Down below, we have the 3b and the b plus 2. So look for any factoring you can do here, and you just try it real quick. And I see that if I was to factor this, it has to be a 7b and a b, and numbers that multiply to make 4, but the outside terms and inside terms subtract to make 6. Well, it'd either be a 4 and a 1, but those aren't going to work. So 4 from 7 is actually 3. So I could try a 2, but this ends up making 14 minus 2 ends up making 12. So that's not going to work out. So it looks like that is the factored form. So oftentimes you're not going to be able to do a whole lot of reducing on these problems, but you always do look for anything that you can factor. And if it is a trinomial like this with no common factors, look to see if possibly b plus 2 is a factor or 3b, but neither are, so we'll just leave it like that. So on this next problem, I have the same situation. I do not have a common factor in the denominator, even though they both have n's. This is 1 more than n, this is just n. So I need to multiply by the other's denominator. So n plus 1 over n plus 1 on the left, n over n on the right. So the key on this one is that whenever we've got subtraction, we need to add the opposite, otherwise we're going to end up making an error. So what I'm going to do is I'm going to change this subtraction to addition, and I'm going to change both of these signs to their opposite. So the key is, when you do this, you've got to change the numerator's signs, every term in the numerator, to its opposite sign when you add the opposite. And so from there I can go ahead and multiply. So I have n plus 1 times 9 makes 9n plus 9. In the denominator, or in this next part of the fraction, continuing on in the numerator, n times negative n makes negative n squared, and then I have a negative 8n. And then down below, just write the terms as factors, n times n plus 1. So you collect like terms in the numerator, negative n squared plus n plus 9. There's no factoring here because we don't have numbers that multiply to make a negative 9. If I went ahead and factored out the negative, that would subtract to make 1. So that's the factored form there, so I just have n and n plus 1. So the nice thing about these adding and subtracting problems, typically you're not going to do a whole lot of reducing, but definitely look at the trinomials, see if they could factor as one of these factors. You don't have to get the factored form, just look to see, is n plus 1 a factor of this? So try it. You just do n plus 1. Well, the number to make 9 would have to be n plus 9. And to make one of them negative, I have to put a negative sign in front of maybe this n to make a negative n squared. But you see how the outside and inside terms will not make one n, so I know it doesn't work. And so I know that this will not reduce any further. So those are the types of problems you're going to see on this assignment. Good luck.